Okay, so last time we were talking about oxidation numbers and assigning oxidation numbers to individual elements in a compound. And so I thought we would go ahead and do some more examples with oxidation numbers. So my first example here, um, if you have an element by itself, an uncombined element, its oxidation number is going to be 0. Okay, and that's also is the same for diatomic molecules like Cl2. Its oxidation number will also be 0. Anytime you have a single element that is uncombined, it's not a compound at all, its oxidation number is going to be 0. Now, there's an exception there if you have ions, so monatomic ions. So, for example, if I have like Al plus 3, this is a single element, however, it's an ion, so the oxidation number for an ion is going to be whatever the ion's charge is. So in this case, this is aluminum plus 3, so its oxidation number is going to be plus 3. What if I have Cl minus? So the oxidation number for Cl minus would be minus 1 because that's the charge on the ion. So if I have something like a polyatomic ion, like nitrate, for example, so I have the strategy with oxidation numbers is, you have certain rules for certain elements, and some elements you don't have rules for at all. And so the strategy here is to assign the oxidation number for the element that you know, and then use math to figure out the one that you don't know. So here for oxygen, we have a rule. Oxygen is usually -2 unless it's in a peroxide, and so I'm going to go ahead and assign it a -2. One thing that gets students mixed up, the oxidation number is always per atom. Okay, so here when we're trying to, I'm going to try to calculate the overall oxidation number for nitrate. It has to add up to -1, but that's for all the oxidation numbers for all of the atoms, all added together, have to add up to -1. Why -1? Because that's the overall charge on the polyatomic ion. So I know oxygen's -2. Let me go ahead and use a different color here. So oxygen's -2 here. I don't know what nitrogen is. Okay, so what I'm going to do, I'm going to multiply the number of atoms times the oxidation number of -2. So that's 3 times -2, that's a -6. That has to add up to -1. All right, so with that -6 plus whatever nitrogen happens to be. So I don't know what nitrogen is. There's only one atom of it, so 1 times x plus -6 is equal to -1. So in my head, I can say, well, x has to be +5, right? So +5 plus a -6 is a -1. Now, if I wanted to do this algebraically, I could say 1 times x plus -6 is equal to -1. So x minus 6 is equal to -1, and then add -6 to or add +6 to both sides. And that cancels out, and you have x is equal to a +5. So you could do it that way too. If you wanted to do it algebraically, you could do it, or if you could just do it in your head, -6, I need a +6 for it to be 0, but it's not 0, it's -1, so it needs to be +5. So however you want to do it is up to you. But anyways, now I know x is +5, so that is the oxidation number on nitrogen. Now, notice that the 1 there represents the number of atoms I have for nitrogen. Sometimes you don't have one atom of nitrogen, sometimes you have more than one. And so that's when you would end up, if you're doing it algebraically, you would end up just doing the math and getting it here. But if you do it in your head, whatever your overall number was, so say for example, if my overall number was 15 and I had 3 nitrogen atoms, it would be 15 divided by 3, which would be 5. Okay, and you would do that algebraically if you ended up doing it solving it as if it's an algebraic equation. Okay, so let's try another one, another compound that has more than one element, and it's also neutral though. So this example here, calcium hydride. All right, so here we know that calcium is group 2. So this is actually an easy one because we have rules for both of these. Calcium's +2, right, because it's group 2. Hydrogen is usually +1. However, in this case, it's going to be -1 because it's bound to a group 2 metal. Okay, so when you have two metals, well, hydrogen and a group 1 or group 2 metal coming together, you're going to end up, hydrogen is going to end up being -1 instead of +1. Now that hardly ever happens, but here's the problem. Okay, so say for example you forgot that hydrogen could be -1, and you assigned it +1. So if I assigned it +1, you would run into a problem here. Of course, all the sum of all the oxidation numbers have to add up to 0. And so calcium, there's one atom of it, so 1 times +2 because it's group 2. And then if you said that, okay, so hydrogen, there's 2 atoms there, and it's +1. So +1 times 2 is +2, +2 times 1 is also +2. So 2 + 2 is 4, it's not 0. So something has to be negative in order for this to add up to 0. And so you realize that then that hopefully you would remember, oh, this is not +1, this is -1. So hydrogen can be -1 when it's combined with a group 1 or a group 2 metal. All right, so in that case you have 1 times +2, which is +2, 2 times -1, which is -2, a +2 and a -2 are going to cancel to give you 0. Okay, so your oxidation numbers listed would be calcium would be +2, hydrogen would be -1. Okay. All right, here's another one here that it's one of those that you may not see very often, but you have to know how to solve anyways. So you have hydrogen and you have oxygen. So we know hydrogen is +1. It's not with a group 1 or 2 metals, so there's 2 atoms of it. This is a neutral compound, so the sum of all the oxidation numbers have to add up to 0. And so there's 2 atoms of hydrogen. It's +1 because that's the rule for hydrogen, plus 2 atoms of oxygen. And then oxygen here is going to be, it has to be either a -2 or a -1 in case of peroxide. All right, so let's say that you said it's -2. We're going to see a problem here because here's 2 times 1, which is +2, and 2 times -2, which is -4. That is not going to equal 0. All right, so that's going to equal -2. So we have to go back and say, okay, what did I do wrong here? I mean, this is the math. It's not adding up. So what can be an exception? So we know hydrogen has an exception if it's bound with a group 1 or 2 metal. We just saw that in the previous example where hydrogen was -1. But oxygen is not a group 1 or 2 metal. So that means that maybe I should apply the other rule for oxygen. Oxygen is normally -2. But in this case, this is called hydrogen peroxide. It's the stuff you pour on an open wound. It fizzles up and it basically disinfects open wounds and kills bacteria. So it's peroxide, and so this -2 for oxygen is not correct. It's going to be instead -1. So 2 times -1 is -2, and 2 times +1 is +2. So you get it in the case here where you have 2 times 1 plus 2 times -1, which is equal to 0. Okay, so my hydrogen oxidation number would be +1, and then for oxygen it would be -1. Okay, hardly ever happens in case of hydrogen peroxide. Different peroxides are going to have a -1 oxidation number for oxygen, but that hardly ever happens. But expect exceptions. Okay, so because your book is gonna and your tests are gonna want you to remember exceptions, because those are important to remember too. All right, so here we have iron 2 oxide. And so breaking the elements down here, we don't have a rule for iron. Iron is a transition metal. Most transition metals we don't have rules for. Actually, I don't think we have rules for any transition metal. So, because they're variable. Sometimes they can, with iron, usually it's either +2 or +3. For oxygen, we have a rule for it though, so we're going to assign it -2. Okay, so here I'm going to assign oxygen oxidation number of -2. For iron, I don't know. Okay, this is a neutral compound, so I have to add up to 0. So what I need to do here is do the math. So I have 1 atom of iron, so 1 atom of iron times its oxidation number, X, plus 1 atom of oxygen. Its oxidation number I know is -2. So 1 times X is X. 1 times -2 is -2. Okay, so then X plus -2. All right, so I'm going to add 2 to both sides. So plus 2 plus 2 there. 2's here cancel out. I bring down my X, so X is equal to +2. All right, now if you wanted to do it in your head, you could do that. Well, this is -2, so this has to be +2. There's only 1 there, so it's +2. You could do that too. So either way you want to do it, it's fine. So those are the oxidation numbers. Iron's +2 and oxygen's -2. So that's it for iron 2 oxide. All right, so this next example here, N2, nitrogen is it's an uncombined element, so this should be an easy one for you. It's just going to be 0. And you're going to see that when we start to talk about single replacement reactions. You're going to see how you're going to have just single elements. And you're going to have to assign its oxidation number of 0. Okay, so just keep that in mind. All right, so here we have next example, KCl. So for KCl, we end up having, wouldn't say we have a rule for halogens, but most of the time I assign them as -1, okay, for an oxidation number. Technically, though, we don't have a rule for it. So for potassium, we have a rule, though, because it's a group 1 metal. Okay, this is a neutral compound, so all the oxidation numbers have to add up to 0. I know potassium's +1 because it's a group 1 metal. Okay, so knowing that, now I can figure out what chlorine's going to be. So there is, let me move over here. So there's 1 atom of potassium times its oxidation number of +1. Plus there's 1 atom of chlorine. Its oxidation number, I don't know. Okay, they all have to add up to 0. So 1 times 1 is 1, plus 1 times X is X. Okay, so what I'm going to do, I have a +1 here, so I'm going to subtract 1 from both sides. Right, so X is equal to -1. All right, and again, you don't have to go through this grueling process, right? If you know this is +1 here, this guy has to be -1. So you can do that in your head very easily, okay? And like I said before, with halogens, normally I'll assign them an oxidation number of -1. Sometimes it's not good practice, but I guess when you've done this enough, you kind of know when you can assign it and when you cannot. So the best thing to do is just to stick to the rules, assign what you absolutely know based off the rules that you have, and then use math to figure out the ones you don't know based off of the math. All right, so here for this example, potassium phosphate, we have to make sure that it adds up to 0 because, you have 3 elements here, but it's a neutral compound, so the sum of all the oxidation numbers have to add up to 0. I know potassium is a group 1 metal, so it's going to be +1. Okay, so there's 3 atoms there, so 3 times +1 plus 1 one atom of phosphate, I don't know what its oxidation number is, and then plus 4 times negative 2, and it's getting cramped here, so I'm going to move over here and write the same thing. So we can do a little bit of algebra. Okay, so 4 times negative 2 is a negative 8. And that all adds up to 0. Okay, so 3 times 1 is 3, and that's coming from potassium. And then plus phosphate, I don't have a rule for that, so that's 1x. Plus oxygen, 4 times negative 2. I know this is negative 2 for oxygen because that's a rule. So overall, it's negative 8. Okay, so that adds up to 0. So 3 plus x minus 8 is equal to 0. So here I have x. Here I have plus 8, so I'm going to add 8 to both sides. Okay, and here I have plus 3, so I'm going to subtract 3 from both sides. So x has to equal to positive 5. And again, if you saw 3 here and 8 there, negative 8 there, negative 8, positive 3, you'd have to have a positive 5 in order for these guys to add up to 0. So x is 5, so that means my oxidation number for phosphate is positive 5. Okay. So hopefully going over some of these oxidation numbers again is going to help you. The reason why it's very important to do some practice problems, and if you can go online and find a worksheet, that might be the best thing for you to do, because if you can't assign oxidation numbers, you really can't do what we're about to do, which is learning how to balance redox reactions and breaking redox reactions down into half reactions. So that's the next topic that we will